Hello, let's take a look at your MT12 practice test. On the first question, I want to know what's the sample space for getting a sum greater than 10? Well, first off, 5 and 5, is that greater than 10? No, it's not. So that one is going to be false. If we didn't have 5 and 5, I think it would be true then, wouldn't it? 5 and 6, 6 and 5, and 6 and 6. Now let's take a look at problem number 2. And I think what we'll do here is let's actually list out A and B so we can answer the question. So A is going to be generating multiples of 3 all the way up to 30. So A is going to be 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. B is going to be factors of 24. So what goes into 24 will be 1, 2 goes into 24, 3 goes into 24, 4 goes into 24, 5 doesn't, but now we just go backwards. 4 times 6 is 24, 3 times 8 is 24, 2 times 12 is 24, and 1 times 24 is 24. Now on the first one, A complement the union of B. Well, first off, notice that one's false because I just don't have enough even for B when I'm doing union. So B, I would have to have, sorry, trying to get my marker here to show up there. I would have to have all of these. I'd have to have 1, 2, 3. I don't have 3, do I? So it's not the first one. Now, A intersect B, let's take a look at that one. So what's the same? Well, notice 3 is the same. And then we go 6 is the same. There is no 9. 12 is the same. And 24 is the same, isn't it? So that one is definitely correct. Now, A intersect the complement of B. So then I'm going to look at the ones that are not in B. And let's look at those. And I'm going to kind of cheat ahead, and I'm going to look at my choices here. So my first one, 3 is in B, 6 is in B, but 9 isn't in B. So that one would be 9, wouldn't it? Okay. Is 15 in B? No, but it's got to be in A. So it's in A and it's not in B. That works out. 18 is in A, but it's not in B. That one works out. 21 is in A and not in B. That one works out. 27 and 30. Oh, so that one works. So A intersects the complement of B is also correct. Now if I'm going to look at A union B, so I'm going to list them all out here. I have to have everything. And notice I got a problem. I don't have 1 listed, do I? Because my 1 is in B. It's got to be in A union B, so it's not that one. So now let's look at the complement of A intersect with B. So I'm going to look at, pretty much I'm going to look at backwards like I did on the one above. So I got 1, and notice that's not in A, so that's good. I've got 2, that's not in A, so that's good. I'm going to highlight these because this looks to be good so far. I've got 3, but that's in B, so I don't want to include that one. 4, 4, no, 4 is right. 4 is in B and it's not in A. But then I've got 5. Is 5 in B? No, it's not. So that one's not correct. Finally, we'll take a look at A union the complement of B. So I'm going to list everything in A. So I'm going to list everything in A. So I'm going to go, A should have 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. Now I'm going to list things that are not in A, or the complement of B. So I don't want 1, I don't want 2, I don't want 3, I don't want 4, but I do want 5. Okay? I don't want 6, but that's already included. Okay? So then 7 I need to include. We don't care about 8. And then I'll do 9, 10, and 11. And then 13 through 23. So 13, 14, 15, 16, 17, 18, 19, 20, and 23. And then anything beyond 24. Oh, that's all of them, isn't it? So we have 3 answers on that one. So I should have A intersect B, A intersect the complement of B, and A union the complement of B. On question number 3, we've got a randomly chosen group of 3 people. What's the probability there will be at least one girl? Well, at least one girl, if we think about that, means it's the complement of all boys. So I'm going to take 1 minus the probability of all boys. I guess I could make a tree diagram here also if I look at it this way, because if I think my first child could be a boy or a girl, my second child could be a boy or a girl, and my third child could be a boy or a girl. And notice every single strand except one has a girl in it, doesn't it? Okay, the first strand has all boys, but every single one has at least one girl. Okay? And so in other words, there are 8 of all boys would be 1 out of 8 or 7 out of 8. I could just count 1, 2, 3, 4, 5, 6, 7 out of 8 would give me at least one girl. Sometimes you might have 2 or 3 girls.